right, welcome to this edition of MLSecOps Podcast. Today we have special guest Sierra Haex, who was actually a former coworker of mine. We were both on the research team at Coalfire doing security research, 5 years ago or something?
Yeah, definitely, yeah.
Yeah, and so now we're both doing research into AI and AI security, which we've been doing for several years now. We kind of started together doing research for Protect AI.
Yeah.
On the original Hunter Bug Bounty program.
Yep. Right before everything blew up.
Yeah, I think you were like one of the very first testers of AI supply chain security on that bug bounty program. That was 2 years ago.
Oh my goodness, time.
I know, it's been a long time.
Yeah.
So now you're doing, explain what you're doing now with some of the AI research that you've done recently.
Yeah, so in the past year or so, I've been helping DARPA out with their, DARPA H, with their AI XCC competition, where we are testing the limits of AI models. My current role in that is to build challenges that test AI's ability to find vulnerabilities in programs, with the end goal of actually going and securing all of the infrastructure that underlies the internet, all the invisible stuff, so that another Log4j doesn't happen. So
Right.
it's a really fun mission, and it's a really good time.
It's interesting because the path that we both have taken essentially was we started with looking at the whole AI ecosphere and saying, hey, what's new in this? Like when an organization adds AI to their departments for whatever reason, they're doing sales research or they're using an LLM as a chatbot for customers, you're going to have an ML machine learning department. And that department has security issues that don't really exist in other departments that traditional security can't necessarily cover. But there is quite a bit of overlap between traditional security and AI security. So
Absolutely.
When we started all this, we looked at that and we saw that the supply chain was probably the most vulnerable part of an organization that chooses to start employing machine learning models and agents and LLMs. And that's where we started. We started with looking at tools like Ray, for instance.
Oh, yeah, absolutely.
What was some of the research that we did on Ray? Because we actually did this together. We were texting it on the phone, I think, at the same time, looking at some Ray code.
Yeah.
What is Ray, first of all?
Well, Ray is a AI system that is used to ingest data, and then you can perform queries against the model that you trained. And you had messaged me, and we kind of just jumped on it at the same time, and we were just going through it as fast as possible. And we discovered a couple very vulnerable things in it. And one of the things with AI is that AI has components of it that are unique to AI, but there's also a lot of components that are just overlap with infrastructure.
Right.
And so the vulnerabilities in web testing and reverse engineering and code analysis also apply to these systems as well.
Right.
So we were performing code analysis against Ray.
Yeah, and so what Ray also does is it creates a cluster of computers to train models. So it's used by a lot of the major organizations, like I think Uber and Netflix, I think, uses Ray too. So Ray allows you to build models on distributed sets of computers, like massive amounts of computing power. And it's used by a lot of large companies. But the issue was, because the speed of development was occurring so fast and still is,
Absolutely.
A lot of these tools are being built out by machine learning engineers, and there's not a lot of security testing going into it. Or else they'll just say, hey, listen, we put this product out here, it's not that secure. But here's some guidelines that you can help secure it, only run Ray in an isolated instance with access to absolutely nothing else or something like that.
Yeah. And that's a product of just how fast the industry is moving, how quickly new things are developing on AI.
And it's not this is not a knock against developers of these AI tools either that we found all these bugs in. It's just the first to market is getting the biggest chunk
Absolutely.
of the utility and the user base and all of that. So it's a function of the speed of development, not necessarily a function of the engineers and everything are dumb and bad.
Oh, no, not at all. It's just, yeah.
But it's something you got to think about when you are employing machine learning in your environment. A lot of these tools have now been security tested. And so we started doing security testing. We found some remote code execution, some pretty big issues from a hacker's perspective, because these things are remotely attackable. So if someone sends you a phishing email, for instance, and they have a link to they have a link pointing to your internal Ray instance. If you click on that link, that's remote code execution.
Yep.
Arbitrary code that the hacker wants. So it doesn't matter if Ray is not exposed to the internet or anything like that. It's still a fairly big security hole. So when you're thinking about how to secure your organization from external threats in your AI environment, supply chain, I think, should be a fairly large portion of your time spent. Check out the previous CVEs, just do some basic security testing on any of the tools that you're using, and you can avoid things like the Ray remote code execution.
Yeah, and there was a couple of ways we even attacked that, where we went after like the management software, then we went after like the individual compute node, and we were able to kind of look at it from a holistic attack surface.
Right. And so this was all just traditional security testing. This said we didn't use LLMs to find these bugs. We weren't attacking LLM models. We're just using the infrastructure that stands up these LLMs. And so this kind of brings us up to visibility. In a lot of environments, I feel like a mature IT organization knows exactly where all their computers are. They have it all organized nicely. They know where this IP address goes to. They can tell when this computer is connecting to this printer and that sort of thing. I don't see that really in organizations that start deploying models internally. A lot of times it's like the Wild West, where the machine learning engineer has to just download whatever they can to get the job done. And there's no central organization of, where are these models stored? What data was this trained on? Was this trained on personally identifiable information, HIPAA compliance data, credit card information?
Right.
All that stuff is kind of nebulous right now. And so if you are in that role of trying to secure the AI infrastructure in your environment or your organization, figuring out where all these things are and putting constraints and limits on where machine learning engineers can store models and things like that is going to help a lot. So centralized databases like MLflow is a pretty good example.
Absolutely.
It's a good place to store all your models. Centralized repository, just tell your engineers, this is the only place we're going to put this stuff, or if you're in the cloud, that makes it a little bit easier. So Amazon has Bedrock. Bedrock has, a central repository of where all your stuff is. It makes it a little easier to organize. But that organization and visibility feels very, very important to eliminating these bugs that we saw when we were pen testers, especially where non-mature organizations would have a Windows XP box just like randomly lying around somewhere.
Yeah, an old NT4 domain server.
An ATM machine that ran Windows XP. Definitely saw that several times.
Yeah.
So to avoid all of that, I feel like your first job is to figure out what tools are your machine learning engineers installing, what models are they downloading, where are they downloading those models from, and have all those models been scanned. And I think one of the parts of AI security that people overlook is the model file itself.
Oh, yeah. Because usually they are like Python files, and they're unpickled into like an AI system. And so that in Python, unpickling things is inherently unsafe because there's ways to run code through that process. And it's not needed most of the time because models are usually just a set of point vectors, and you just need the dimensions of it and load the point vectors in. But some other models contain additional assets and ways of tweaking them. And so the industry has kind of shifted into this pickled format for if you're looking at Python models. But it's inherently vulnerable. And if you open it on your box, like it'll run code.
Right. And antivirus, we did this testing. Antivirus doesn't detect malicious models like at all. Malicious models just go under the radar. So you can't just use traditional antivirus techniques to be like, oh, hey, Microsoft Defender flagged this model file and said, oh, it's going to execute some crazy code on your computer. You got to actually scan it with like model specific scanners. And so places like Hugging Face, Protect AI actually runs Guardian, which is a tool that scans model files, a model file specific scanner on Hugging Face to determine whether the files are malicious or not. And of course, this is never going to be absolutely perfect. There's going to be 0 days that sometimes pop out. But this is just one area where traditional security measures like antivirus, they just don't overlap with AI. This is like very unique to AI is model files themselves.
Yeah, and Hugging Face is an amazing platform to share and learn from other AI developers, but there currently there's no malicious code scanning in place. So scanning is super important before you bring that code down into your environment and run it.
Yeah. So this kind of brings up the idea of security of AI versus AI for security. So what we're talking about so far is like the security of AI, the infrastructure around it, where you're downloading the models, how to use the models safely. So it's not, you're not putting a chat bot out that says, hey, you can buy this car for $1 and being legally obligated to sell it. But the AI for security is actually an interesting topic too, that's been developing quite rapidly. what you were saying with using LLMs to augment your security research. Can you go into a little bit more detail about how you're using that to augment fuzzing or something like that?
Yeah, oh yeah, absolutely. Because if you look at like a DARPA's work, they're trying to defend the internet. But another component of my work is looking for bugs and writing exploits for them. And so when you have a massive amount of code, it's very hard for a human to go through 20 million lines of code, retain that state in your head, and then see issues or trust problems that develop in the code. So I've been able to take binaries, run them through a disassembler and decompiler. I use Binary Ninja. And then I get pseudo C code, and then I can submit that to ChatGPT or Gemini or some of the other systems and say like, hey, look at this function. Are there any bugs inside of this? And if so, tell me about them. And then from there, you can use like basic bug finding techniques that the models know about, the code models specifically. And then from there, you can use directed graph analysis to find paths between user input into the program and then where the vulnerable function is. And so it's a really cool like developing area that is yielding a lot of good results. So
yeah, LLMs just have this ability to like conceptualize, contextualize massive amounts of data.
It's surprising.
It's crazy. And so we're watching this like play out in real time. So we have, the rise of the hack bots is starting to come now. There's tools like Expo who claim to have the benchmarks that are about equal to a senior level pen tester for web application tests. Like it finds 0 days. They actually have HackerOne. Expo is running on HackerOne, and they have a whole bunch of different vulnerabilities they found on HackerOne just using an LLM. But it is a very different topic to talk about security of AI versus the security using AI for security. Right. We actually have a little bit of overlap there when we built Vulnhunter, which is a web application security tool that goes and reads code bases and finds 0 days, remotely exploitable, 0 days. And that kind of stuff, I think, is probably where the future of like security as a whole is going. Like, where do you see everything going in, let's say, 2 years? We have several new generations of models. How does a security professional start using those models to secure their own environment?
Well, I think it's just going to be part of the CI/CD system. You're going to have a model looking at all the code that developers create and submit as like your first line of defense against injecting vulnerabilities into like a code base.
Yeah,
and
that
then
makes perfect sense.
Of like reviewing all the existing code that your company has, all the legacy things that built up over the years, the technical debt. Using a system that can look at that data in mass and then find bugs is going to be super valuable.
Yeah, I think the CI/CD pipeline makes perfect sense. Like GitHub has Copilot. I can imagine that's very easy to just pop into your CI/CD pipeline. So whenever you put a GitHub PR in there, it just scans it and says, oops, you have made a little mistake here. Right. Yeah, I see that absolutely as being like the fundamental change and shift in security. I think that can probably apply too to like AI models and stuff too. Like you download an AI model, another AI actually just analyzes the model itself. It can probably decompile it, open it up
all the way down. Yeah, we can definitely.
Which actually reminds me of DeepSeek. So DeepSeek is super cool, but I feel like there's a lot of misconceptions. So can you explain like what the DeepSeek release was and how it compares to the other models and why this is somewhat controversial?
Yeah, so the reason why DeepSeek is such a big deal is the cost of training models that say OpenAI uses ChatGPT were in the like billions of dollars. It was a ton of money to like get the data, ingest it, and then using like the best hardware on the planet, they were able to train these models. The thing that really kind of shook the industry was that DeepSeek didn't have to have that upfront cost. It was just in the millions, I believe. So it was like orders of magnitude cheaper to develop. They didn't need the best hardware in the world to train their models. And it's been kind of like an upcoming revolution. There's even more recent models that came out like day before yesterday. I believe it's called S1, and it was trained on like $50 worth of Grace Hopper GPUs. And so
insane.
Yeah. And each of these models, they're tested against a benchmark of questions. And a lot of these models are like at PhD level, answering PhD level questions. And it's wild to see the progress and how quickly things are jumping.
Yeah, the moat is just not big around the major like model creators anymore.
Right.
DeepSeek is also a Chinese model. which has brought consternation to some people in the industry because they don't want to share their data with the Chinese. And I feel like, just to clear up a little misconception here, DeepSeek is an open source, open weight model, meaning you can read and edit and change it however you want. There does not appear to be any way of the model file itself sending data back to China. It's been scanned by many other people to make sure the model file itself has been safe. Mm-hmm. It is when you get it from a reputable source, like Hugging Face, for instance.
Yep.
The only issue you would have is if you use DeepSeek's API. You go to chat.deepseek.com. That is sending data back to a Chinese server and a Chinese company. And, they're free to do with that data whatever they want. If you just download that model in your environment, you're not exposing risk to yourself of data exposure. You can also just edit the model to do whatever you want. So, you want to make sure you're downloading an official release of it.
Yeah. And Hugging Face is actually a really good place to get it from because
trustworthy.
The team has actually been recreating DeepSeek's model based on their paper that they released. So, there's some really cool work coming out of Hugging Face.
The DeepSeek model itself is a test time compute. It competes with O1. ChatGPT's O1 is where it sits there and it has a chain of thought. And it's kind of funny to watch it think. It goes, but wait, there's this other variable in the code that I didn't think about. But wait, it really chats like a human to you. It's very cool. But I don't think that it's really a risk for U.S. companies to use this model because it's open source and open weight. And that's a very, very important fact to know when you're trying to secure your personal organization and you're using external models.
Well, and it's such a productivity boost as well, because if you look at ChatGPT, the amount of compute required to run that, you can't run that locally.
Yeah.
But you can run DeepSeek locally.
Yeah, if you've got, 4 A100s?
Yeah.
I mean, it's a little expensive, but I mean, I think it's cheaper than, if you were to import all of the mixture of experts that ChatGPT has, for sure. So we talked about supply chain security. That's the APIs, the infrastructure that you use to build the models, to train the models, to store the data, all that stuff. That's area number one that you want to focus on when your organization deploys AI.
Absolutely.
Then we talked about the model files themselves. That's kind of area number two, which is unique to AI itself. So you can use tools like Guardian or Model Scan to make sure that your models are safe. But also with that goes the visibility of do you know when that model was trained? Do you know what data it was trained on? All of that stuff kind of fits into the supply chain aspect of this too.
Right.
Step 3 would be LLM security. And so I think you have some thoughts on specifically threat surfaces for various deployments of LLMs.
Oh, yeah. So considering if you're deploying within your company LLMs, you have to kind of look at, is this going to be external facing? Is this going to be internal facing? If this is external facing, how much can your customers or just random people on the internet, how much can they do to your system? Is it plugged into APIs on the back end? Could it be used to compromise your network? But also on the internal side, if you want to train your own models, you also need to be very cognizant of the sort of data that you feed it. Are you feeding it customer data? Are you feeding it PII? Are you feeding it PHI? What are the relevant laws around your jurisdiction as you do that?
Data security becomes a major issue when you're using it internally.
Yeah.
But also you have to make sure that not just the training data itself, but also a lot of these tools are using RAG databases. And so it seems like you got to make sure that what the RAG database is ingesting is not going to spit out something that the user is not supposed to have. So access controls on LLM feels like a very underutilized sort of security measure right now.
Yeah, there's definitely a lack of controls around it and a lack of visibility and introspection as well.
I see the most common pattern of deployment for internal LLMs is a RAG database which an LLM can connect to, and it's usually surrounding some internal documents, either documentation of a service or just documentation of some product that your company puts out.
Right. These are the support bots that you get redirected to when you go to a company's website and you're like, I want to talk to a human. These are actually querying just a series of documents that the company has published.
Right. And so you have to be careful to make sure you're not putting in sensitive information on the RAG database. Mm-hmm. And I think that the access control problem is just there's no good framework. There's just nothing out there you can just plug and play and say, I only want these people to have access to this data in the RAG database. All that kind of control stuff can be done in SQL, in traditional databases it can be done. I don't really see a good solution at the moment to do those access controls on these LLM applications like that.
Yep, absolutely, yeah.
So what about agents? This is the future, I feel like. Today is the LLM applications, but agents Define what an agent is.
Well, an agent is like a discrete model that lives on hardware that you have or your own computer, and you're able to query it, and it's able to perform actions on your system for you. So an example of this would be like, I need help making this type of function. I'm a coder, and like I need you to write a chunk of code for me. And then it'll kind of introspect your question and then actually spit out some text into your code editor. Well, this comes with an inherent vulnerability of like, how much access do you give it to your system?
Right.
Like what's the power in that? And then also, how much do you trust the model having access to your system?
Right. And so it comes back to, there's really no access controls around the tool usage of these agents right now.
Mm-hmm.
And so the danger of the agents, of an internally developed agent, would be like an RMRF of your whole disk. Hey, this agent's supposed to just clean up log files once in a while. You just tell it in natural language, clean up the log files today, and it goes and deletes your entire home directory. How do you control against that? Right now, I don't think there's a wonderful way of doing that. It's just a threat that I think you should have in the back of your mind if your organization is deploying agents. And I think this is the year that organizations will really start deploying agents.
Well, and I think they're exploding because they're extremely useful. Like they're a productivity boost and like
insanely helpful.
Yeah. And as we move along, I'm sure bad things are going to happen.
Yeah.
We just have to keep developing things around.
It's like when we were looking at the infrastructure 2 years ago, all these applications that supported machine learning models and stuff that we found were just full of holes, like Swiss cheese on it, like hacking in the 90s. I think agents are going to be that coming up because everyone wants them and they're so useful.
Yep.
Like, did you see that OpenAI had released a couple agent frameworks?
Oh, no, do tell.
They had Claude first released MCP, which was computer use.
Right.
So we can like actually take control of your computer. And then OpenAI just released Operator framework, which you can schedule it to do tasks, and then deep research, where deep research is amazing. It's so good. It just collects all this information from the internet, digests it for you. I mean, what would have taken you 8 hours to put together a mediocre report, it can do in 20 minutes, if that. So those operators are incredibly useful. The paradigm we're seeing with agent deployment right now is the OpenAI paradigm where they control the agent.
Mm-hmm.
But I think it's not a far reach to create your own agents in-house. It's just not that difficult, and they have a lot more flexibility. So I think when you start creating agents in-house, the security risks are there, and there's not a lot of solutions to the security risks of the agent overreaching. You'll have to put those constraints in manually at this moment, I think.
Absolutely, yep. And as models get smaller and more efficient and they become ubiquitous and just in products that we use, there definitely needs to be an oversight of security as they are implemented.
Right, which I don't have a lot of faith in organizations to do that themselves, because I look at router security,
It'll be fine.
Router security, well, everyone needs a router, and so we have all these different routers, and they're all just full of holes. It's like, it's been 15 years, and we're still dumping router vulnerabilities, despite the fundamental security nature of those things.
It's wild.
So we are here at Wild West Hacking Fest. Me and Marcello Salvati gave a talk here. Sierra is joining us. And we want to give you a big shout out to Wild West Hacking Fest. It was a great conference. It was really fun to hang out with everybody here in Denver. So once again, I'm your host, Dan McInerney. Thanks for listening. This is Sierra Haex, an AI security expert, even though she doesn't want to admit it. I think the field is so nascent. If you've just been doing it for 6 months, I think it's pretty fair to call yourself an expert at that point, even though we've been doing it for years now.
Well, thank you so much for inviting me. I really appreciate it.
Yes, and we'll see you all next time.